Hey everyone, welcome to part 5 of our DevOps Masterclass. And in this lesson, we're actually going to dive into secrets. That's what the S stands for. But first, as always, if this is useful, a like, subscribe, comment, and share really is appreciated, and hit that bell icon. So what I want to cover in this session is really understanding, well, why do we have secrets in the first place? Maybe how can I avoid having secrets as part of our overall solutions? And then how can I securely store those secrets if I do have to have them? Don't forget, this is part 5 of the masterclass, as I've kind of talked about before, and it's in the description. So there is the GitHub repository, and I'm adding to this each week that has kind of the content, the links to the videos, other assets, and of course the playlist, where we actually go into, you can see all of the different lessons actually in order. So with that, why do we even have these secrets in the first place? And you can really think about, well, I have my application. So I've got my application that I've written, and the reality is very few things are an island today. My application probably wants to maybe talk to some other resource. Maybe it's a database, a storage account, another type of application service. Maybe it's actually going and talking to some other cloud-based service. Maybe there's something it wants to talk to through REST, but it has to go and communicate to those things. Now, to talk to those things, generally, that is not anonymous. I have to have some kind of authentication which then authorizes me to perform certain things. Now, that authentication may be a token, it might be a credential, maybe it's some kind of access key or signature, but it basically boils down to I have some kind of secret that I have to actually make that work. If I think about DevOps, now remember with DevOps, the whole point is, hey, we have these pipelines. Well, those CI/CD pipelines, or maybe just other types of workflow, other types of automation, well, they're working with other things. Those pipelines, hey, it might need to actually go and create resources. It might need to go and talk to RESTful APIs. It might, and very commonly will, have to interface with my DevOps tooling. Maybe it has to go and update a work item, talk to something else. Maybe I'm talking to some repository for containers, all these other types of things I actually have. So this need to authenticate is kind of everywhere. I have to have this ability to talk to other things. So I need a place to actually put those secrets that enables me to use other services. Now, I'm going to say this multiple times. Never put secrets in code, in configuration files. Never put them anywhere where you're just typing these things in that's then going to go in a file, be it a JSON file, an INI file, hard code it somewhere that you then go and put into a repository. Be it public or private, it's going to end up there. And if it ends up there within 10, 15 minutes, some bad actor's going to find it, use it, and you're in a world of hurt. So this kind of cardinal rule, if you remember nothing else but this, never put your secrets in your code. Now, there are things that actually help us protect from this. I talked about actually in the previous sessions, things like GitHub. So GitHub repos will actually go and scan for secrets. And if it finds the secrets, it will do various things to protect me. And this is enabled by default for public repos. So for public repos, I'm just going to kind of look at this. This is a kind of a GitHub article. And it talks about for public repositories, it has all these partnerships. So things like Adobe, Amazon Web Services, Azure, Discord, Doppler, Dropbox, GitHub itself, Google Cloud, all of these different services. And what it's going to do is for these services, if it finds a secret and something you've checked into the repo, well, it will actually go and contact the partner. Go and contact Azure if it finds a shared access signature for a storage account. And then that partner can make the choice. Hey, do they revoke it? And do they notify the owner or something else? Now, if it's a private repository, well, at that point, I need that kind of advanced security add-on for GitHub private repositories. And then once again, it has a whole list of partners, but you can also add your own custom types of scanning within the organization. So you can actually now do other types that I have, my own custom patterns. And for private repos, it kind of talks about, hey, it's going to send an email alert to the repository administrators, to the contributor that actually committed the secret, and it's going to kind of display an alert in the repository as well. So the only point I'm kind of trying to stress here is these are things that will help you if this bad thing happened. But still, cardinal rule is don't put them in the code in the first place. I don't want them there. So that helps protect us, but don't let it get to that point. But accidents happen. So where should we put them? As an organization, we may have a certain direction. Do I use a certain type of central common vault? Is there a certain technology we like to use? And I'm going to look through a couple of patterns how I can actually think about secrets. What I definitely want to avoid is in my overall solutions, I don't want islands of secrets. I don't want every single type of pipeline and resource and deployment technology having its own little stores of secrets. And I definitely don't want the same secret being stored in multiple places, because then I have this whole problem of, well, if I rotate it, do I have to go and update it in 5 different places? How do I secure all of those different things? It's really a painful point for me. So as much as possible, if I am going to have a store, I want it centralized. That makes it one place for me to actually go and make sure it's really locked down. I can essentially control the authentication, the authorization. I can even use things like policy. So if I do have a secret, I can use policy to say, well, what's the lifetime for this? How often does it have to be rotated before there's some alert that will actually go and say, hey, you have to go and create a new version of this secret? Because I probably don't want really, really long-lived secrets in my environment. So let's think about the best type of secret. And the best type of secret is one I don't actually have to have at all. And that seems kind of weird. But I want to go back to this idea where we have an app and it needs to talk to other things like other types of resources. I use the idea of a storage account or a database, and that's super common. So let's take a scenario that we're using the cloud. I'm going to use Azure as an example, but other clouds have kind of a similar idea of this. I'm going to start with a very simple scenario where, hey, look, I have a virtual machine. Now, again, I'm using the idea of virtual machine. We'll call this VM1. But realize there's many types of compute service. This could just as easily be a function, something serverless. It could be a container, a whole host of different things. So it's some type of compute where I'm going to run my applications. So inside that, I have some app that performs a certain function. Now, what I need to do in this case is, it could be a database, but I'm just going to say it's simple. It's a storage account. And that storage account has kind of various blobs in it that I want to interact with. Now, that would mean I'd have to have some way to authenticate. I'd need maybe a credential, an access key, which I'd have to store somewhere. I want to try and get away from that. So we have the idea that, well, we have an identity provider. So in Azure, this is Azure Active Directory. So this is the IDP, the identity provider for Azure. And what we can actually do is, instead of having to have a secret that this app would have to go and read to then use to talk to the storage, well, this compute resource can have its own identity. So what we can actually do is create something called managed identity. So this is kind of like a service principle that we'll see in many different types of cloud service, but it's managed for us automatically. Like in AWS, this will be a service linked IAM role. So I can do a similar type of thing in AWS as well. And the whole point now is this VM actually has an identity in our Azure AD, our identity provider. So I can think about, well, this VM has an identity, VM1. And what I can actually do in the role-based access control of my target resource, again, I'm saying a storage account, but it could be anything. I can actually say, hey, that VM1, I can give it a certain role. Maybe it's a blob, saying on the data plane, a blob reader. So the managed identity for this resource has a role on the resource I want to talk to. So now what happens is the application running inside that resource, it can actually go to the identity provider and it can say, hey, I need a token, please. And it knows the app is in VM1, so it will actually give me this token. So it's giving me the token. I can then use this token against the storage. So that token is for VM1. So now it says, hey, VM1, you have blob reader. I can now actually go and get access to those things. Now I've got detailed videos on managed identity. I've got a 360 kind of overview, and then I actually go through kind of unattended authentication. Those links are in the GitHub repo, and I'll try and link up in the top corner of the YouTube as well. Let's just kind of see this though super quick. So if I was to jump over, I can go and look at my virtual machine. And what we can see here is we have this identity option. And if I go to identity, I've turned this on. So we can see it actually has the principal ID. So it has an identity. So then with that identity, I can give it access to resources. If I go to my storage account, for example, and I'll pick my storage account, well, there's access control of my storage account. And if I look at my role assignments, what we can actually see is, well, a couple of different things. Firstly, I gave that VM the reader role, but that's reader at the Azure Resource Manager level. That's kind of the control plane. Then I also gave it the storage blob data reader role. So it has this role as well, i.e. it can actually go and interact with blobs in that particular storage account. So it has that ability. So a process running inside that virtual machine can now request a token for that VM, and only something running in that VM can get that token that it can now use to talk to other things. Now this is perfect if, hey, it's just this one resource needs a set of permissions. What if I have 20 VMs, like a web farm, that all need the same role-based access? I don't want to do 20 lots of VM 1, 2, 3, 4, 5, 6, 7. Well, then there's another type. There's a user-assigned managed identity. So this is actually a different resource. If I just search for managed identities, you actually see I created a managed identity called Saviltech1. And I can then give different resources the right to use that. So that same VM, actually for user assigned, also has access to request a token as that user assigned. So 20, 50 different resources could all be given permission. And that could now be given role-based access control permissions, just like that system assigned. The application would then have a choice. It can say, hey, give me my default token, which will be the system assigned that only that resource can be. Or it can say, hey, give me a token for this user assigned Saviltech1 that, again, I've delegated certain specific resources can use. Now, I don't want to go into a huge amount of detail about this. Most of the compute resources actually support this. And again, this is Azure specific, but other clouds will have kind of similar ideas around this. You can see pretty much all of the key types of service support this idea of a managed identity. So it's very easy for one type of resource to get permission as itself to another type of resource. So this avoids the need for me to having to go and store a bunch of secrets or anything else. So the whole point, there's no secret stored here. It's essentially, hey, I am VM1, and as VM1, I can be given access to certain things. Like as a human being, instead of having to remember a password, it's a biometric. It's who I am will give me access to things. That's kind of like the managed identity. So that's fantastic, but what if that's not an option? What if I'm talking to something that doesn't support managed identity, it's outside of whatever my cloud is, or it just doesn't work with managed identity? I need a secret, be it an access key or a credential or something else. Well, then we store it somewhere. We need a vault. Now, again, all of the major clouds on premises, there are vault solutions. I'm going to kind of talk about the Azure one because that's something I'm most familiar with, but it's just the idea of this central place. So here what we have is we have the idea of a vault. And the whole point of what this vault is going to do is it's going to securely store different types of artifacts that I care about. Now, these are hardware security module based. So they're actually backed by these hardware components to help ensure the security of whatever I put in it. And there's different types of things I can put in it. So I can put in secrets. So a secret is something I can kind of read, so I can read it back out of the vault and I can write it, I can update it. I can think about there are things like keys. Now, a key is something I can generate within it. I could import it in, but I can't get it back out of. But what I can do is once the key's in there, I can perform cryptographic operations within the key vault. Hey, decrypt this or encrypt this or validate this signature. And there are things like certificates. So it can do lifecycle management. I can use those in various services. It could maybe go and update it for me. Again, in my example, I'm going to kind of show Azure Key Vault, but all of the different cloud platforms have this. On premises, there are vault solutions, like HashiCorp has a vault solution. And one of the benefits this has, it has things like versions, so I can actually rotate these. I can see the previous versions. It's centralized, so it gives me that kind of single place to go. There are different role-based access control. So actually, Azure Key Vault actually has two. It has kind of a policy-based one, then it has a newer role-based access control where each individual secret can actually be given access to different identities. So it's a lot more granular than the old policy-based thing. And again, I've got videos that go into detail. That's linked in the repo. Now, the nice thing about vaults is, hey, I have all these different types of things. It can integrate with my pipelines, but I have to be able to get to it. So you need to remember, hey, what are the network communications to actually get there? And I have to authenticate it to the vault. So we can take the same example. If I'm this app, and maybe there's a secret. So let's say there is secret 1. Well, as the application, I want to use it. So I'm like, okay, I have to auth. So how do I authenticate? It's a chicken and egg problem. I don't want to store a secret in the app, but I have to authenticate to the vault before I can get access to this access key or shared access signature or a different credential. Well, remember, I have that managed identity for this resource. So what I would actually do is for here, I would say, hey, VM1, you can be a secret user just for that one secret. So now I authenticate as the managed identity, VM1, which has access to just this particular secret that I can now use. So I'm now solved the chicken and egg problem. I'm using my managed identity to authenticate to the vault, and then I can give that identity access to specific secrets. So that's kind of how this can all fit together. So let's kind of see this in action. So if I jump over to, let's firstly actually go and look at my key vault. So I have two key vaults. So I've got this old Savile vault, and the reason it's old is it uses this old access policy, so this vault access policy, which didn't give me granularity at an individual secret or key or certificate. Basically, it would give certain users access to all keys and all secrets. So what we prefer is this new Azure role-based access control model. So now each particular secret or key or certificate has its own access control. And what I've actually done here is, if we go and look, there are data plane roles, and there is this role of key vault secrets user. And I gave the managed identity of that demo VM that key vault secrets user. And again, remember, I set it at the secret level, so it can only access that one secret. So it's only that specific secret it actually has access to. So the demo VM has access to this secret. So if we jump over, this is the demo VM. So I'm actually logged on to the demo VM. And right now I'm actually looking at its temporary storage. If I do a refresh, it's empty. So what I'm going to tell it to do is, hey, I want to do a connect AZ account as a PowerShell command. Connect dash identity. I'm not passing it an identity. I'm just saying connect as your default identity. So that will actually go and use the managed identity. And you can see it's actually done that already, because we can see here the account it's used is MSI 50342. Now if I get my AZ context actually from over here, you can see, yep, I'm in my subscription, I can see my account. So what I'm going to do now is I'm actually going to try and get a file. It's from the storage account I showed you earlier, where, remember, I gave that managed identity the blob data reader function. So I'm actually going to try and fetch a file as that managed identity. So if we execute that, okay, we think it worked. So we can go and look, oh, what file? So we're in here. Now there's a new file, and voila, there's my dogs eating cereal out of a bowl. So we can see that worked. So I didn't have any credentials stored in there, it just acted as itself. Now I can go and actually go and look at, well, what is the service principal for an actual resource? So that's, hey, my demo VM. I can actually go and get the various identities. So that's getting my VM object and then looking at the identity. So that's the principal ID. That's the same one I showed you when we looked at the managed identity of the VM. But what I want to do, I want to go and get a secret. So we're actually now going to go to my Azure Key Vault and grab secret 1. Now remember, secret 1 is where we're looking here, and that's where Demo VM has Key Vault secrets user. So I'm saying, hey, I want to grab the secret, and we'll actually say, hey, let's get the secret value from there, and then we'll output it. And my mind-blowing secret is password. And if we actually go and look at this secret, look at the current version, notice it has versionings. Yep, it is password. So what we did there through all of those various steps was exactly what we drew on the board. The VM, the process inside, in this case it was a PowerShell window, said give me a token of my default identity. Then it used it to be a blob reader to go and get some blobs. Then it used it to go to Key Vault and get a particular secret. Nowhere did I ever have a credential written down. Nowhere did I have some file that I read in, an access key from. Nowhere in my code did I have any of that. It was using just the inherent resources identity in my identity provider. And then if the resource I wanted to talk to didn't support managed identity, i.e. I needed an access key, well, I can store the access key in the vault, use the managed identity to get to the vault, and then I could get that key, and now I could go and use that to talk to something else. So that's kind of the exact process we want to really go through. But nowhere in this pattern did I actually have a secret. Now, there's going to be times where, hey, I'm running in something where maybe it doesn't have any kind of managed identity. So I still always have this kind of initial vault problem. Now, maybe if it's on premises, I can use things like an inherent credential manager, maybe as part of the operating system. Maybe there's some native kind of domain membership of the resource itself to actually go and get to things. Many application services have some kind of local option for storing data. For example, if I was to go and look at something like an app service, but again, we start getting into these islands, so I really want to minimize this. But if I went and looked at my app services, for example, and just looked at a web app, one of the things you'll see under configuration is you have these various values I can store that are encrypted. But these will surface as environment variables to the app running inside this particular app service. For general app configuration, there's things like Azure App Configuration. That's kind of that central management for all my key value pair-based configurations. So there are different options available for that. But again, I wouldn't want to store a huge amount of things in here because now I'm getting into those islands. But maybe there's something I have to store there because, hey, I can't use a managed identity. This is not a good example because I can. But I have something, so look at what the options are to store the minimum amount of secret that would then enable me to go and get to some kind of centralized managed solution. But never have it in code. If you find yourself, the only way I can do this is I have to put it in a file, stop, and look again. There must be another way. Be it, again, some kind of local credential manager, maybe there's some vault capability locally I can use. Never have a secret in the code, be it a credential, an access key, a signature. You never want it in the code. So this is all great for my deployed resources. What about my actual DevOps pipeline? What about that automation tooling? And remember, the whole point is, remember, that I have some pipeline. So I can think about, hey, I've got my pipeline. That could be my CI, it could be my CD, well, whatever that is, I have my pipeline. And we talked about, well, that pipeline actually runs on something. For Azure DevOps, it uses agents. If it's GitHub, it has runners. And there was this whole idea that for those things, well, there was options where it could be cloud hosted, or there were options where it was kind of self-hosted. I create my own virtual machine, I install a piece of software that then enables it to go and connect to the pipeline to then run whatever tasks are waiting for it to actually run. So in this example of self, well, you could imagine actually I could have maybe a virtual machine. So I could have the idea that, hey, I actually create a VM maybe in Azure itself. So I'm going to create this VM. Again, my example is this is running in Azure. And I'm self-hosting, so whatever that agent kind of thing is, I'm installing into this kind of virtual machine. So be it the runner, whatever that software, there's something kind of running here that establishes the outbound 443 to our DevOps solution. Then it's listening for, hey, things that I need to be doing. Now, the benefits of this is, hey, I can have things like a custom image. Maybe there's certain tooling I need kind of stood up. It could be persistent, so it's always ready to run. Maybe it's kind of a faster option. But also now, well, if it's my own resource, Well, guess what? I can have things like app managed identity. So that runner, that agent inside there, has an identity just inherent because it's kind of running as a resource. Additionally, this is actually sitting inside a virtual network. Now that can be important because when I think about my pipeline, it's probably doing various things. I might actually have certain resources that my pipeline has to interact with that are locked down. And a common way we lock things down, for example, in Azure is a private endpoint. So it has an IP address within a VNet that actually is the only way to go and talk to that resource. Well, if I have this self-hosted runner or agent, it's in the VNet, it can talk to that private endpoint to get to the resource. So that might be a key point. And again, it has a managed identity that could be given RBAC to that resource. So I've removed the need to have a credential stored somewhere, and I've solved a problem about, well, how do I actually control things like network access? Because those cloud hosted runners or agent may not have access. How would that actually function? So now when I use a self-hosted, I can get the managed identity, I have network access if I do have those kind of lockdown things. It solves that problem. Now that all assumed, this is just a constant environment. If it's not constant, maybe I've got a script, maybe the script will actually go and create these things, create the private endpoint, and then it could actually kind of go and execute that. Now maybe I still need a secret in my pipeline solution. Now remember, one of the nice things I can actually do is pretty much any DevOps tooling is going to have the idea of some kind of local secret capability. Now we actually saw this last week when we talked about the CI/CD pipelines. Remember we had the whole idea that, well, actually this pipeline, this workflow runs within the context of, well, it belongs to some project, or maybe it's called a repo, it depends on the technology. But that pipeline belongs to this. And what I can do is, well, I can have secrets here as well. Now, again, depending on the solution, but in GitHub, for example, I can have organizational level secrets. I can have repo level secrets. And I can even have environment level secrets. And actually kind of cascade down that way. So we have these various options that I can actually put within my pipelines. Now, once I set a secret, I cannot read it back. Now, I can read it from the pipelines, I can get access to it, but I can't go in the GitHub, go and read that various secret. It's also not shown in logs. So if I was to go and get a secret and then write it out, and I'll show you this in a second, it will not show in the logs. GitHub is actually super nice at protecting us from our own stupidity. If I go and fetch a secret from a key vault, for example, and try and write it out, it won't write that out either. It will kind of mask it from me. Now there's no versioning. So some of the downsides, there's kind of no versions. There's no history. So it's obviously different when we compare it to like a Vault solution that actually has those capabilities. I think it's a 64 kilobyte max size for these kind of secrets. If you needed something bigger, I could use something like GPG to actually encrypt a larger secret to make it available. I can have 1,000 organizational secrets. I can have 100 repo secrets, 100 environmental secrets, and a pipeline can use 100 secrets. And the way this would actually work is I would access it as this kind of, well, secret dot, and then the name of that actual secret. So let's actually take a quick look at this. If we jump over again for a second. So if I go and look actually at our pipeline. So this is what we did last week. Now, firstly, if I go to the settings of my repo, now this is not part of an organization, so I have no organizational secrets here. But if you were part of an organization, and maybe I'll switch over later on, you can actually add org level secrets and then set which repositories are allowed to use it. But in this case, if I look at my secrets, you can see the repository has two. It has this greeting one, and then it actually has an Azure credential that I created for this repository to be able to authenticate to Azure and then do other things. And then there's 3 more secrets, each set at a different environment, all called greeting. Because the point is this would override the repo. If I was running something in the test environment and accessed greeting, it will use the environment's version of that. So we can actually leverage that kind of capability. And where we use this, if we actually go and look at our actions and my environment workflow, what we did in here last week, actually 2 weeks ago, is we can see, hey, yeah, look, this one is I'm accessing secrets.greeting. And what I can see is I was running this one on environment test. So it will use the test value of greeting. My next job, I was running it on QA. So it would get the QA version of greeting. Then I didn't specify an environment at all. So then this time it would just get the regular repo level value. And then down here I was in prod, where it would get the prod version. So it would get different versions based on actually where it was. And we saw that actually happening. So if we actually jump back over and look at the executions, let's see one that finished. We could see, hey, sort of send greeting, the first one, output, yeah, it was test. The next one, yeah, it was QA. The next one, yep, it was repo. And the last one, it was prod. And we did something kind of weird to make it show it, because you can't just dump out the value. I had to kind of do this weird compare thing to get this to actually show up. But we can see there we have those credentials available to us. So that was really kind of this key point. So I can use those secrets actually as part of the repository or the environment or at the organizational level as well. So we have those things available to us. Now I want to consider that kind of a bare bones. Again, as an organization, we're going to make a choice. But I probably would not want a ton of secrets in my repo. If I as an organization am making a choice to use like a key vault technology, most likely what I will do is I'd think about, well, yeah, look, these secrets, let's say I'm not using that self-hosted. Let's say I'm using a cloud hosted. So I have to authenticate to the cloud I'm actually going to use. So what most likely I would do is I would think about, well, be it an org or a repo environment, maybe it's different cloud credentials to get access to different production, dev, maybe different auth required. But I would think about, okay, I would get my credential. So that I would store, you saw I had that Azure credential. So that I would have as a secret in the repository. I would use that to authenticate. So now I've done that, so that would be kind of my step 1. So now my step 2 would actually be to kind of authenticate and then be authorized to get access to something in a key vault to then get secrets. So rather than storing a whole bunch of secrets in my repo, and if I've got lots of different repos or spread out, how am I managing those? How am I doing policy around those? Don't all have versioning. I think about in the repo, I just have enough secret to authenticate. And then once I've authenticated, I have the bulk of my secrets kind of stored in the vault. And then my pipeline can actually go and get the credential. Sorry, the pipeline gets the credential from local secrets, then authenticates to the vault and is authorized to particular secrets that it can then use through the rest of the pipeline. So we have these kind of choices that we actually have. And I kind of set this up. So if you look at, for example, GitHub, they have a logon to Azure action. And in the example, it actually shows you how to create the service principal. It gives you this nice JSON output that you can then read into the file. So let's jump over and see all of this. So if I actually go to my Azure AD for a second, and if I look at my app registrations, now I created this using the command in the documentation, but if I search for Git, you can see I've created this GitHub DevOps service principal. Now the way I created that was, if we look at the documentation, so this is the action to log on to Azure, and it shows me how to use it. And notice in this example, it's saying, hey, we're going to use creds secrets.azure_credentials. And if you keep reading down, it actually shows you, hey, look, here's how you would actually go and create that. You would replace the name. You could change the roles it's being given. You could change the scope. And that was going to spit out a JSON file. And I've got this in the repo. I've got a text file showing it's going to spit this content out and a whole bunch of other stuff. You just move the curly braces up and out, and then I would paste that in as my credential. So I actually did this. So I created this. You can see, hey, yep, I've got this credential, this GitHub DevOps, and then I added this actually as a secret here. Now again, I can't read it. I could update it with a new value, or I could remove it, but I can't just, hey, show me this to screen. But it's there, it's that Azure_credentials. But it's just a service principal in Azure. So what I could absolutely do is now that could be given access to other things. I could think about, remember that key vault? Well, on that key vault, that same secret I had before, and if I look at the access control and my role assignments, well, guess what I can do? I can actually give, if I find it correctly, a role. Hey, Key Vault secrets user, I'm going to give to GitHub DevOps as well. So the service principal that I created, I can give it roles on any other resource. So now, if my pipeline authenticates as GitHub DevOps, it can now go to this key vault and read secret 1. So let's put that together. So what I created was a little very simple read Azure key vault. And if we look at what we're doing, I've got it on a manual execution only. And basically, I'm going to check out the repo. So I'm using the actions checkout v2. Then I'm going to log into Azure using that secret. And then I'm going to use the action get Azure Key Vault secrets. And I'm giving it the name of the vault and the name of the secret. And then I'm giving an identity to this step. Now the reason I'm giving the step an identity is what I'm then going to actually do is I'm going to set that secret I read as an environment variable just called secret. So I'm accessing my steps. The step is called get key vault secrets, i.e. the name I just set. I'm looking at the outputs of getting secret 1. And then I'm going to test something. Well, can I just output it to screen? I can't. But then I'm going to try and test it. Is it equal to password? Because we know that is the value. If it is, output this is a match, i.e. I really did read it. So that's what this does. It authenticates using the repo secret, Azure credentials, authenticates to Azure with that credential, then tries to read secret 1, and then essentially writes it out. So that's all this is actually going to do. And if I go and view the execution, so we could just run it now quickly. Let's just run it. And let's let this execute so we can see it's running. We can see the various steps. So it's kind of waiting. So it's setting up the job. And it will go through very quickly. So it's checking it out. So checking out the repo, logging into Azure using that credential. Yep. Now I'm going to try and get the secret. And now I'm going to do something dumb. And look what the dumb thing did. Can I see? No. It actually hid it from me. So even though it's not a native secret of GitHub, and the documentation tells you it does this, because it knows it came from Key Vault, it's still hiding it. It still knows, hey, this is something I probably shouldn't write out to a log file. But notice it did write out that is a match. So we know it actually did get a value of password. So we know that worked. So the key point, what I would now do from here is I could think about, great, I could now use that credential that I fetched from Key Vault to maybe go and authenticate to Docker Hub to maybe push some container images actually to that registry. I could go and talk to some other RESTful service. But I got just enough credential from my repo to authenticate to my main vault, and then I can get all those secrets that are managed by policy, that are centrally controlled. I have all the audit logs too. I'm not trying to manage a million different islands. All I have here is just enough credential to authenticate and use my main vault. Now, I can do anything I want at that point. I've got credentials, I can use keys, anything I want from that vault, I can use. And it's really going to come down to your organizational preference of what you do, what is the direction. But for most, they will try and minimize having secrets scattered all over the place. I will really think about, hey, just enough secret here. If I can't use maybe a self-hosted with managed identity or whatever the native service is, get a credential to authenticate and then have that central management. Now, sometimes my pipeline may actually want to do things against the DevOps service. So the pipeline maybe wants to go and create a work item or update a work item. Well, there's actually a native GitHub token just that's part of your pipeline. And that is basically acting as the pipeline. So I don't have to store a secret or do anything else. I can literally say, hey, secrets.github token, and I can use that to basically be authenticated to GitHub as the repo, maybe go and update a work item or something else. And I had that just kind of listed in the code. I didn't do anything with it, but we can actually see, if I go back up again, I just wanted to just kind of show you the syntax. But you can see I have, hey, this GitHub token, and it's just the same syntax, secrets.github underscore token. I've never created GitHub token. It's just always there for you. And if we look at kind of the documentation, it talks about, hey, we provide this token as GitHub. And again, other solutions, I'm focusing on GitHub here, will have similar ideas. Then it talks about, hey, yeah, I could use that token doing other things, calling a REST API, labeler, what permissions it has. So that is kind of just natively available to me if I need to go and talk to other things. So again, we're trying to minimize having to store things. Let's take advantage of the native capabilities of whatever the solution is we're actually using. Now, this has been very, very cloud focused when I think about this. If I was on premises, things like Terraform, they have its own vaults. There's things like Circle CI to have groupings of these things together. Just check what solutions you have available to you. First and foremost, my key driver is never put secrets, and I'm putting in code, but I mean config files, nothing that's ever kind of written to disk. I never want it in there. Nothing I'm checking into a repo. Not a shared access signature, not an access key, not a password, not a cert. I don't want those things in my code. If you ever find yourself in that position, stop, rethink, relook at what the technologies are, relook at what my options may be. Because guaranteed, if you put this in some parameter file, it's going to get checked in somewhere. Hopefully the solution, like GitHub, will find it and invalidate it for me to save me from myself, but maybe not. and I get kind of attacked with it, and that's a really bad day. So if you remembered nothing else from this session, never put it in code, but examine what solution you're using. Hey, can I use things like managed identity? If it's something that doesn't support kind of that inherent identity, well, hey, I can put it in a vault. Can I use something like a managed identity or assigned in AWS IAM role to get to the vault to then read the secrets? Pipelines have different options, but if I can't just inherently use who I am as the pipeline, well, I have just enough secret to authenticate to a vault. And then I can pull those things down from there and use those. But we avoid having secrets in code. We try and avoid having secrets in the first place. If we can't, we at least store them centrally where I can really manage it, assign policy to it, really lock it down, have the full audit, traceability of it. So that was it. This was the secrets kind of module. Really want to kind of think about those things. I hope, as always, this was useful. As always, a lot of kind of work goes into these, so a like and subscribe really would be appreciated. And until next time, take care.